Hello there, and welcome back to this series about LangChain applications with Redis, right? So in this video, I'm going to show you another use case, a very common use case actually, about how you can leverage Redis with your LangChain applications for the use case of caching, which is arguably one of the best use cases to use with Redis, right? But the important part is that I'm going to show you two different type of caches, right? The standard cache and the semantic cache that probably you might not have heard of before, but I'm pretty sure they're going to love it, right? So just a heads up that all the code that we're using for those videos are available on a GitHub repository that you can find here on the description of this video, the link for it, right? So grab that code so you can follow up and tag along with everything that's being shown here. Also, we're using a Redis database created on Redis Cloud. So if you want to know how to create one, go back to our first video of the series that I show you step by step how to create one for free in there, right? So with that said, let's start discussing our second use case of LangChain applications. So this time you're going to use this Jupyter notebook here called caching, right? And then, just like I mentioned before, I skipped some of the installation of the requirements and the dependencies. Is going to be roughly the same dependencies as before with one difference. This time we're going to use OpenAI because we're going to actually use an LLM in this video today. So we're going to establish conversation with the LLM and using LangChain, use cache it for caching the responses, right? And then I already executed the import, so we don't have to worry about all the imports from the code. And that leaves us with the setup of the Redis connection, right? So this is the construct that you have to use with Python/LangChain to create a connection with Redis. From the Redis package, you call from URL, so you have a Redis client, and then you can invoke the ping operations to see if you are reaching the database. So we're not going to use this kind of a local database. We're going to use the one that we created in the first video in Redis Cloud. So I'm going to actually there so you can see how to retrieve this Redis URL. So click on your database, and then you are going to click on, let me put here myself on the left. So you can see, you're going to click here on this button, connect. And then you are going to use this option here called Redis CLI, right? So heads up, you're not going to copy the entire command here. What we're looking for is basically only the Redis URL, right? So forget about everything before this. Before you copy it, make sure to click on this I button here so you can review the password for your database. So copy this and then go back to your code and associate it with the Redis URL, right? So let's execute this and see how that goes. So as you can see here, it printed true, which means that our ping request was able to reach the database. So we're good to go. The next step is going to be set up your OpenAI API key, right? So in order to do this, you have to make available your OpenAI API key as an environment variable with under this name over here, right? OpenAI API key, right? When I execute it, I have mine already exported as an environment variable, so we're good. If you are not if you're not sure about how to create your own API key for OpenAI, I'm going to put here on the link, the description of this video, the link that teaches you how to create one, right? So if you know how to do this, good, right? Just make sure to provide your API key using this environment variable, right? And then let's start discussing our first use case of caching with LangChain, right? So in this first use case, what we're going to do, and this hence the title standard cache, we're going to use Redis as a standard cache because given a prompt that we're going to send to the LLM, right, we're going to execute the first time, and obviously it's going to take some time to execute. But then the second time, the idea is that instead of the invocation goes to the LLM again, because it's the same prompt, it's presumably it needs to go to the cache because it's supposed to be there already, right? And save the trip to the LLM to execute again, given that is the same prompt, right? This is the use case that we're going to implement here, right? So let me show you this, how the code actually looks like after executing so you can know how it behaves, and then I can walk you through in the code itself, right? But before this, let me show you that on the Redis database itself, currently there are no keys stored, right? And then I'm going to execute this code, right? And then you can see the results here, right? So this is the output of that code, right? So the first call, the one not cached, it came with the explanation of what is a cache. That was the prompt that I provided with. I'm not going to read it because I'm pretty sure it is right, but the important part here is that it took 1 second and 24 milliseconds to actually retrieve this information, which is fast, but I mean, not that fast. The second call, which is presumably the cached one, right, retrieved the same response, but in this case, it took a fraction of a millisecond to actually execute. So that was a speed improvement of 69 times faster, right? Which is what we wanted. The point here about caching with LangChain applications and LLMs sometimes is not only necessarily to make it faster, right? This is a kind of a collateral result of using caches, right? The actual purpose when you are in the context of developing AI applications is necessarily avoid completely the trip to the LLM, because in the end of the day, you know that you have to pay it for that trip, right? You pay per invocation and per tokens that you exchange with the LLM. So for situations that it is the same prompt, it is the same answer, why not cache the results and then give back to the user since it's already processed? You've paid for that invocation already, right? So that's the use case that we're trying to do here, right? And then you can see here on Redis that if I refresh the keys, you're going to see that there is a key here already created in the format of a JSON native data structure. And it's going to use some like specific naming convention for LangChain, right? But the important part here is that it's going to show you everything that was retrieved as the cache. So this is the response that came from the LLM, saying that cache is the process of storing frequently accessed data in a temporary storage location for faster retrieval, right? If we go back to the code right now, let's walk you through in the code. What we did here was we create an instance of a Redis cache, providing the Redis URL, right? So this is good to go. And then this is a construct that is very common from the LangChain SDK, right? So set LLM cache is a way for developers to set globally in your application a cache, right? So in whatever other parts of your application that requires the usage of a cache, is going to be served by this cache that is set globally, right? Or we could have like chosen to set this cache in a per session, per application, per block basis, right? So you have this option as well with LangChain, right? And then we created this function called execute with timing that basically retrieves a prompt as a parameter, right? And then it calculates the start time of that invocation. It performs the invocation against the LLM itself, getting the results. And then it calculates the end time, which is for us to see how long did it take for the invocation to happen. And we return the results and the duration itself. So this is what we actually executed in our code. Our prompt was explain the concept of caching in 3 sentences, right? Very short. And then we executed with the timing, we got the result, the timing, and then we printed out not only the result, but the time it takes in seconds, right? The second call is the call that we're supposed to be cached, right? So again, same prompt. So we didn't repeat the prompt. We didn't change the prompt. And then that's the call that was supposed to be faster. And as you could see in the output, it was very, very fast, right? And then we calculate how much faster it actually is. So the important part of this, actually, it is coming out the clear of the cache, because I wanted to show you the results on Redis Insight. But once you actually finish using caches in general, you have the option to actually clear your cache. So I'm going to uncomment this so you can see what it does. If I execute this code one more time, the results are going to be very similar. But if we go back to Redis Insight right now and update the database, you're going to see that there's no keys more available, right? So clearing the cache sometimes is a good idea, depending on the use case you are developing, right? The important part is that not only you have a programmatic fashion way to clear your cache, but you can also set time to lives for your entries. So that's another way for you to get rid of your entries in your cache, so you don't have to kind of write manual code for deleting the entries, right? So this was the example of what is a standard cache. Now let's talk about of something that is also a cache, but I would call this cache a smarter one, right? And I will explain why it's smarter, right? This is what we call a semantic cache. This is a construct that Redis developed a while ago, and then we're making widely available in our partner frameworks like LangChain and others. And we're actually allowing people to use the concept of a cache in the context of AI factor applications, right? So let me explain how that works with one example. I'm going to do the same thing again. I'm going to run the code and walk you through in the results, right? And then after I walk you through in the code itself to see how it does, right? So I'm going to execute this code right now. So you can see the results is executing, right? And then you are going to be able to see that the idea of it, right? So the original query that we had was, what is the capital of France, right? It is Paris, we know, but we were asking this to LLM. And then the LLM responded as, the capital of France is Paris, right? So that was the response coming from the LLM. And to retrieve this response, it took 2 seconds and 18 milliseconds, right? Fast, but not that fast. But then we provided not necessarily the exact same query as before, but something similar, right? Semantically, the same question, but different words, right? So we basically, can you tell me the capital city of France, right? And then the capital city of France is Paris, as you can see, is literally the same response, but this time it only took 48 milliseconds, right? So that was 4 times faster than before, right? But just like the example before, the point sometimes is not only getting the responses faster, but to avoid the trip to the LLM for similarly already answered questions, right? So I'm going to show you here the keys that were created inside Redis. So this is the LLM cache that was created as a construct from LangChain. And as you can see here, there are all the questions and the answers that were provided and some embeddings as well being used, which is what we call the prompt vector. So this is actually the embedding that was created. Because in the end of the day, this applies the concept of a similarity search, the same one that you have seen on our previous video when we used Redis as a vector store with LangChain. The same concept Redis implement built in as the concept of a semantic cache. So let me walk you through in the code so you can see the difference, right? So what we've done here, first of all, we've used OpenAI embeddings to actually create embeddings, right? And then we've instantiated, instead of creating what we've created before, a standard Redis cache, this time we've created something called a Redis semantic cache, right? For you to operate with a Redis semantic cache, you have to provide, obviously, the Redis URL, where to reach the Redis database, an engine capable of creating embeddings, because as I just showed you on Redis Inside, an embedding that is the equivalent of a previously asked question has to be created so a vectorial search can be implemented behind the scenes, right? And a distance threshold, which is basically just like the K parameter for vector searches that we've seen in the previous video. It is also a level of tolerance that you can apply for how much precise or loose you want the results to come in, right? And then, just like we've mentioned, we've done before, we've set this cache as a global cache using the set LLM cache construct from LangChain. So whenever you have to use caching, the same cache is going to be used. But this time is a cache that not only can be used as a standard cache, but it can also handle semantic operations. This is the beauty of using a semantic cache from Redis, right? So the prompt that we used was, what is the capital of France, right? So we store this on the original prompt, and then we use it basically the same function that we've created before. So execute with time, and this function is defined here on the previous use case. And then we've printed the results and printed the time, just like before, right? And then we've executed the second invocation with the semantically similar prompt. And then we basically changed it. The similar prompt was, can you tell me the capital city of France? So this is what we call semantic meaning of things. Like, as you can see here, those are precisely the same questions, just ask it differently, right? And this is typically what your users in your AI applications are going to do, because they sometimes might not use the same words as other users has used it before. But what matters is that sometimes the semantic meaning of what you're looking for is the same, right? And just like we've done with the previous cache example, what you want, besides bringing your responses faster for your users, is sometimes to avoid trips to the LLM for things that were already answered, right? So, of course, for you to actually realize how much confidence you have on something that is already, the concept of already was answered or not, that's why you need in your testing use calibrate and effectively decide of how much of a distance threshold you are going to apply, right? So 0.2 is very, very close. So that means that we're looking for exactly answers here, almost exactly answer, but you can put higher numbers here. So you can make usage of something more loosey in terms of how close the vectors are going to look like, right? But this is a very powerful construct that is available on your arsenal of APIs building your LangChain applications. And now that you know that Redis can be used not only as a cache, but as a semantic cache, I would highly encourage you to start using this with your applications, because this is going to save a lot of time for your users and a lot of money for your company. So keep that in mind when you are developing applications that require faster responses and not so expensive ones, right? And just like we did before, the semantic cache has a way for us to actually clear all the data that is in there. So we've just cleared, and then if we inspect Redis inside right now, we've deleted all the keys that were already there. Regardless, like I mentioned several times, you also have the ability to set time to lives for each one of those entries so they can automatically expire depending on your use case. Perhaps the duration can be the duration of a session of your user within the web application that you're providing them. So you can use the same session to set the value for your time to lives. And after this, since the session for the user expired already, you no longer have to use this. Or perhaps if you want to reuse similar already responded answers from different users, you can come up with a different idea of what is the expiration for this. Perhaps it's 24 hours or a week. I don't know. It highly depends on what you're trying to accomplish by reusing already processed answers. I hope this content was useful for you, and I'm looking forward to see in our next video where I'm going to show you how to make usage of another great feature that LangChain provides, which is the concept of chat history, right? Along with Redis. There are a couple of good things that you're going to see there, but just like I said before, I'm not going to spoil the surprise of the next video. So I'm looking forward to see you in the next video.